This is a puzzle called the M24 Cube. It's called that because it has turns like the 24 Cube or Little Chop, but you can't make all moves at all times, and the restrictions make it so that the possible positions form the group M24, which I believe is a first for puzzles of this type. The way the moves are restricted is that the first move you make has to be a clockwise one. That's just a matter of the mechanism. Obviously, clockwise and counterclockwise end up the same, but it has to be a clockwise one, and then the next one has to be a counterclockwise one, but not just any counterclockwise one. It has to be one where the edge points in the same direction. So this face doesn't turn either way, but this one does. It turns counterclockwise. And so, of course, you can undo it. Now I'll show you a scramble. Sometimes the moves get a little bit stuck, but if you can get anywhere in the move, you can tell that the move is actually a legal move. Another thing you might notice is that I decided to make the puzzle not cubical, and instead had some sort of a pillowed shape. In fact, the outer shape is actually the intersection of 3 cylinders. I just did this to save space. Alright, now this is relatively scrambled. Alright. So that was the M24 Cube. Thank you for watching. The M24 group has too many interesting features to talk about in this video, but a lot of them actually can show up on this puzzle. For example, this alternate coloring, where it alternates colors around the cylinders. Is a representation of what is called the sextet group, meaning that if you ignore specifically the colors and just where the colors are different, this puzzle, which started off before the alternating as having 24 factorial over 2 positions, or like 300 sextillion positions, down to the original one, which had only about 245 million, down to this puzzle, which has 1,771. A lot of the other subgroups have similar stickerings that are interesting. Like, if you pretend that the red and orange are the same, the purple and blue are the same, and the green and yellow are the same. You get a different group called the octad subgroup. The mechanism is probably simpler than you might think. It only has 4 pieces and 2 layers. The main part of the mechanism are these little toggles with these notches cut out of them. So an axis, when it rotates, can move the toggle to the other position and back, but it blocks it from going the other direction. So on this first layer, we have 3 of these toggles, one for each pair of edges that point in the same direction. On the second layer, we have 1 single toggle for all 6 axes. These 2 layers in combination cause it so that the overall puzzle has to go clockwise and counterclockwise. But when you move just one of a pair, it forces the other one to have to move clockwise next. But the other 4 axes that could move are forced by 1 toggle to move counterclockwise, and the other toggle to move clockwise, and so they can't move either direction.